Welcome back all the fans and followers of space fiction. We all know that landing on the surface of the moon is very dangerous. To increase safety, various backup systems are used in aviation. On Earth, mainly passive safety systems are used. Passive systems are, for example, parachutes, wings, or balloons that only work in an environment with a thick atmosphere. These systems are very safe because they are very simple to operate with a minimum number of parts prone to failure. But we can't use any of these passive systems on the moon because there is no atmosphere there. So how could we make the moon landing safer? First, we must divide the mission to the moon into two main parts: landing and takeoff. A spacecraft that will land on the moon must have a backup propulsion system. In the event of a failure of the primary propulsion system, no passive backup system can be used. The backup propulsion system must therefore be able to either return the spacecraft back to lunar orbit or complete the emergency landing without endangering the crew. However, an emergency landing only makes sense when there is a permanent crew on the moon capable of finding and rescuing these castaways. Otherwise, such a system would only prolong the suffering of the crew. In both of these cases, it would be appropriate if the spacecraft could get rid of the primary propulsion system, because a broken propulsion system is just an unnecessary cargo that requires spending some precious fuel. This method was also used by the Apollo spacecraft, which was able to separate the landing propulsion system from the ascending module with crew cabin. And if a spacecraft contained a cargo module in addition to a crew cabin, it would also be convenient to be able to jettison this module in an emergency too. If there had been no malfunction during the spacecraft's descent, the next very risky milestone would have been the actual landing on the surface. Even if the propulsion system is functioning flawlessly, the spacecraft can still be damaged during landing. The result may not be immediate killing of the crew, but the damaged spacecraft will trap them on the surface of the moon for a period of time that they may not survive. Especially if the spacecraft's mission did not include a long-term stay on the moon. However, this problem can be solved very easily if there is always an empty spaceship ready for departure at the landing site. In addition, the crew that had just arrived would always leave their spacecraft on the surface even if the landing on the surface was flawless. This would ensure safe rotation of the spacecraft for departure from the surface, and each subsequent crew would have an option of using a replacement spacecraft in the event of a malfunction during landing. If a landing failure occurs, it would of course be necessary to send at least one new unmanned backup spacecraft back to the surface of the moon before the next mission arrives. The last and no least risky stage is the departure from the surface of the moon. The crews of the Apollo program had no backup system during the departure. They had to rely on the flawless operation of a single rocket engine. If the primary propulsion system had failed, the crew would certainly have perished. Therefore, the new spacecraft should also have a backup propulsion system for departure from the surface. And again, this would not have to be able to save the entire spacecraft, but at least the cabin with the crew. Depending on the time when the system was activated, it should be able to either place the cabin with the crew into the moon's orbit or land on the surface. In the second scenario, however, It would again be necessary to count on the existence of a permanent crew at the lunar base, which would be able to pick up the stranded crew and bring them back to safety. In the event of an emergency landing, the impact of the crew cabin on the lunar surface could be cushioned by a system of inflatable airbags. In order to save the crew in an emergency landing at the beginning or at the end of the mission, a free landing corridor would also need to be considered. Just as high-rise buildings are not allowed to be built in the path of airport runways, so too should the landing and takeoff trajectory on the Moon not be directed over difficult terrain. The crew of the lunar base must have a good view and quick access to a potential emergency landing site. And this is a fact that is currently being omitted in the planning of missions to the lunar poles. So I hope that your next trip to the Moon will be pleasant and safe. Thank you for watching, and don't forget to click a subscribe button if you want to see other amazing videos from the world of space fiction. And if you want to share with us your opinion, just leave a message in the section below.